Good morning, students. Today we are going to see the data mining techniques. It is an essential topic in chemical engineering. Data mining techniques for extracting patterns and trends. As we advance in industrial automation, our processes generate vast amount of data. The challenges we face is how do we extract useful insights from this data? This is where data mining becomes indispensable. In this lecture, we will explore various data mining techniques and their application in chemical engineering. So, data mining has become an essential tool in modern chemical engineering for extracting meaningful patterns and trends for complex data sets. With the advance of advanced sensors, automation, and computational techniques, large volume of data are continuously generated in chemical processes as we are aware of it. Analyzing this data set effectively can improve process efficiency, optimize product quality, enhance safety, and drive innovation. The importance of data mining in chemical engineering processes generate complex data sets from laboratory experiments, industrial production, as well as from process simulation. Manually analyzing this data is inefficient. Data mining enables us to detect hidden patterns leading to anomaly detection, process optimization, predictive maintenance, product quality control, and waste reduction. So, what do you mean by anomaly detection? Identifying the potential issues before they escalate. Process optimization, finding optimal processes condition to improve efficiency. Predictive maintenance, reducing downtime by predicting equipment failures. Product quality control, ensuring consistent product specifications. Waste reduction, minimizing material loss and environmental impact. So, the very good example in chemical engineering perspective is a chemical plant producing polyethylene needs to monitor variables such as temperature, pressure, and catalyst concentration. By applying data mining, engineers can optimize conditions to improve polymer quality while reducing energy consumption. Data mining techniques in chemical engineering has been classified as under 5 categories. One is classification, clustering, regression, association, rule mining, principal, component analysis. These are the 5 important techniques serves as a unique purpose in data driven decision making. We will go and see one by one. Classification. Classification techniques categorize data into predefined groups. This is widely used in quality assurance and safety monitoring. Decision trees simplifies decision making in hierarchical process. Support vector machines excellent for complex classification problems. Neural networks useful in deep learning for chemical process prediction. So, in terms of chemical engineering perspective, I can give an example. A pharmaceutical plant classifies drug batches as acceptable or defective based on process variables like temperature, humidity, and mixing speed. Classification models helps in early detection of faulty batches, reducing waste and improving efficiency. This is one type of classification. Next, we will move to the next classification is clustering. Clustering techniques group data based on similarities, helping in segmentation and anomaly detection. So, there is a under which we have k-mean clustering divides data into k clusters for analysis. Hierarchical clustering useful for understanding relationship between variables. DBS can density based spatial clustering of application with noise effective for identifying anomalies in process data. So under the clustering, I can give another example in terms of chemical engineering perspective. In polymer manufacturing, clustering helps categorize different polymer samples based on the viscosity and molecular weight. This enables the identification of optimal processing condition for each category. Next subdivision is regression analysis. So I mean the next classification, under the classification, the next one is regression analysis. Regression models predict continuous variables by analyzing relationship between input and output parameters. Multiple regression analyzes the impact of multiple variables. Polynomial regression capture non-linear trends in chemical reactions. As we know, the non-linear equation and that leads to the the non-linear trend will help you to get a non-linear equation. Obviously, to solve this type of problem is very complex in nature. Chemical engineering example. In catalytic reactor, regression models can predict the reaction yield because on variables like reactant concentration, temperature and pressure. This helps in optimizing the reaction conditions. So our next classification is association rule mining is one of the classification in data mining. So the association rule mining identifies relationship between variables in large data sets commonly applied in formulation and quality control. A priori algorithm identifies the frequent patterns, whereas FP growth algorithm analyzes the large data sets effectively. So in chemical perspective, the example for this association rule mining is that a fertilizer, just imagine a fertilizer company finds that a certain raw material composition lead to a higher nutrient release rate. Using association rule mining, they refine the formulation to enhance the effectiveness while reducing cost. So the last one is principal component analysis. Principal component analysis is dimensionality reduction technique that extracts most significant variables while minimizing redundancy. The very good example in chemical engineering perspective is that in an oil refinery, principal component analysis is used to reduce the number of monitored process parameters while retaining the essential insights for optimal production control. So we have seen all the five classifications under data mining. Now we will move to the topic application of data mining. So the application of data mining mainly in process optimization, fault detection and diagnosis, product quality control, environmental monitoring, drug development and chemical formulation. So process optimization. By analyzing the historical data, chemical engineers can identify optimal process condition, reducing cost and improve efficiency. Whereas in fault detection and diagnosis, data mining helps in identifying the abnormal patterns that may indicate process faults or equipment malfunction, enabling predictive maintenance strategies. So the predictive maintenance in the last class we have seen actually. So what is predictive maintenance and so on and so forth. Okay. So the next one is product quality control, improving consistency. That is very important. And environmental monitoring, ensuring regulatory compliance. And drug development, speeding up pharmaceutical innovation. Pharmaceutical and chemical industries use data mining to analyze experimental data, leading to faster development of new compounds and formulations. So what are the challenges in data mining? Despite its benefits, data mining in chemical engineering faces several challenges: data quality issues, complexity of chemical processes, computational requirements, and interpretability. So, coming to the data quality issues, incomplete or inconsistent data can affect predictions. Complexity of chemical process requires advanced computational models. Computational cost. Large scale data processing is resource intensive. Model interpretability. Some machine learning models lack transparency. So, the very good example, challenging examples in terms of chemical engineering perspective, a petrochemical plant struggles with the sensor drift, leading to noisy data. Engineers must pre-process the data before applying machine learning models to ensure accurate predictions. And coming to the data trend, I mean data mining and thing. So the future trend in data mining for chemical engineering is promising with the emerging trends such as integration with the artificial intelligence, big data analytics, real-time data mining. So integration with the artificial intelligence, enhancing the predictive modeling, big data analysis, managing vast amount of process data, real-time data mining, enabling faster decision making with IoT sensors. So very good example in chemical engineering perspective, AI-driven predictive maintenance in an ammonia plant uses real-time vibration analysis to anticipate compressor failure, reducing downtime. So the final conclusion regarding the data mining techniques, classification and challenging. So I would like to conclude today's section with these few words. Data mining is transforming chemical engineering by enabling data-driven decisions that enhance efficiency, safety, and innovation. By embracing these techniques, industries can optimize operations, reduce cost, and improve environmental sustainability. Thank you for your time, and I encourage you to explore data mining further in your own research and applications. Thank you for the time. We will see in the next class very shortly.